This is a screencast on how to sketch and interpret graphs which represent everyday situations. We're particularly in this screencast going to look at how we interpret, which is a word that basically means to read and understand. And there are some little strategies we can use to do this. I'm going to emphasize these in a couple of examples. Graphs are used in everyday situations, whether it be financial markets, whether it be sporting statistics, range of places. And it's really important to be able to pull that information out and identify trends and patterns. So let's have a go. So here we have Sam's saving account. And it's a line graph. Now the first thing to do whenever we read a graph is to look at the axes. The y-axis and the x-axis. That's a really important thing to do because, and the other piece too, the title. Those are the two important bits of information to read first. Title, because that tells you what the graph's about, and the axis because that gives you the intervals. So up here I know that I'm talking about dollars, and you'll see that it's going up in amounts of 20 as we go along here. While along here I can see this is 1997, JFMA. I can quickly infer that these are the months of the year, right through to 1998 to 1999. So it's about a 2-year period that we're seeing here of the Sam savings. Now, you noticed I've already prepared some questions down below. So let's say we were asked a question, how many dollars did Sam save in his account in December 1997? December 19. So the thing to do is, okay, well I need to go to the x-axis here, x-axis being the horizontal one, 1997, December, move up, and as you can see I've moved up to here, and if I then track it along that line, and I can see it's $100. In which month in 1998 did he save $80 in his account? So what I need to do is have a look along here. When is it at 80? And I can see it crosses 80 just here. So again, I'm using both the axis, the y-axis, to give me the information in, because I need to go on here. Here's 80. And I can see very quickly that is September of that year. Draw a circle around the part of the graph that shows when Sam was taking the most money out of his bank account. Now this is where we've got to identify a trend. So if you look at the broad trend of this, it's kind of isn't saving much. Took a little bit of money, put a little bit back in, didn't take any money out, then saved a bit more, then saved a bit more, take out, and then you'll see it starts dropping here, which indicates that he is withdrawing a lot, and that's flatlining. So this piece here is the piece that I'll draw the circle around, because that's when he taking most of the money out of his bank account. And what does the flat line between November 1988, so if I go to that now, so here, and April tell you? Well, it tells me that he was neither saving nor was he spending money, or spending his savings. So it probably means in this period here, what I could probably infer is that he had a major purchase of the thing that he needed to, and didn't need anything else for the next time period. So if we look at a different graph here, the same thing applies. First thing I'm going to do, read the title. So travelling by car. Then I'm going to read the axis here, and I can see the y-axis here, that it's from Whakatane to Auckland. And I can see this is the distance from Whakatane. So Whakatane is at 0 because we're at Whakatane, so it can't be a distance away. And as we go further up here, we get closer to Auckland. So Auckland must be 300 kilometres away. And then if I read the other one here, it says the time of the day. And it looks like we go from 9 AM right through to 3 PM. Intervals of 1 hour. So, now this graph is different from the last one because we have two lines. two trends happening. We also have, and they've labelled the lines, we have Jane's car and Tony's car. And it says down the bottom here, the graph shows car journeys for Tony and Jane. Jane left Whakatane at 9 AM and Tony left Auckland at the same time, as you can see. So, the very first question they have, at what time did Jane arrive in Auckland? Okay. So then what I need to do is, this is the Jane line here, so I need to follow that line until she's at Auckland, which is right up here. And so that time there is 2 o'clock. Again, using there's Auckland there, using the y-axis to give me the x-axis answer. Let's try that one. How long did it take Tony to get to Whakatane? And the amount of hours. So he left at 9 AM. See? He left at 9 AM and he got there at 1 PM. So if I just do some simple maths, that's 4 hours long. Next question, at 11:30 did Jane increase or decrease her speed? Okay, so with this one we have to look at Jane's line, and sorry, the time was 11:30, so let's use our axis. So 11:30, here's 11, so the halfway line there must be 11:30. So if I go to Jane's line, and you'll see here that this is fairly straight, and then 11:30 it changes angle and it goes up at a more steeper gradient. Now what that probably indicates is that steeper gradient actually means she's going at a faster rate, because if she was continuing at the same speed she'd be going this direction. She's actually increased her speed in this case. She's covered a greater distance in less time, so she's increased her speed. How I can tell from this graph is the gradient is steeper of that line. The slope is what I mean by the gradient. What speed was Jane travelling between 12 noon and 12:30? So 12. If you go to 12, here's 12 and 12:30. She was travelling. Did she travel any distance? No, she didn't. She was travelling 0 k's. Now, which probably indicates she stopped for lunch. What was Tony's average speed for the whole journey? Okay. And the way you would calculate that is he has gone, if we were looking at this, he's gone 300 kilometres in 4 hours. So you need to go 300 divided by 4, which is equal to 4 divided by 30, and you could just calculate that out. I'm not going to do that now. And the last piece, that's what you do to calculate average, and the last piece that we want to look at is what was Jane's average speed for the whole journey, and you do the same thing. Divided by put the average, the speed, the overall distance in, which is 300, divided by how many hours it took her, which took her 5. Okay, so that's how we read. So just to recap, recipe says read the axis, look for obvious trends, and obviously the thing that I've forgotten to write down there, read the title carefully.